We'll start by looking at passive design, passive solar design, whatever you might refer to it as, and look at thermal efficiency and home energy ratings within your home. Now, I'll be sharing a lot of information, and as we get started, I want to point out the information is not just for homeowners, but this information would also be useful for anyone that may be looking to rent an apartment or a house, or perhaps purchase a house. It could also be used for designing a new home. When a lot of the design parameters can certainly be used to design a home, but they can also be used to compare two different homes or two different apartments as you're looking at which one of them is more energy efficient. So keep that in mind. Don't tune this out if you think, oh, I'm only renting. It does have an impact in terms of what house or housing unit you select. You might pick a house that is on an end unit, and it might not be as energy efficient as one that's more centrally located within the building. And so we'll kind of weigh some of those design parameters and considerations as we go through this today. But I'll start with looking at the house shape and orientation. And if you look at the figure I've shared at the top, it's just comparing two very simple designs. You might have figure A on the left would be like a standard studio apartment, and option B might be a longer, maybe a ranch style home. They are the same floor space. And so I just use simple numbers on the top to keep it the math simple, but the floor space is the same. It's the area of the floor, and this is a bird's eye view of both units. So unit A is 2 times 2. Unit B is the same area, it's just 1 times 4, but they have the same floor space. But the difference comes into fact by the shape. Okay, so you have the square on the left and the rectangle on the right. And what this does is it changes the amount of wall space that you have. And so if you recall, if you participated in our weatherization webinar about 2 weeks ago, you'll know that when we talked about weatherization, we saw that heat is lost through the wall of any home, through windows, doors, and even the wall itself. And so you can have air leaks, you can have conduction through the wall. That's the importance of having good insulation in your home. But any wall space that you have can be an energy loss. And so we want to keep heat where it should be. So we have a cold winter. It's really cold temperatures today where I am here in Washington County. I'm sure it is for most of the state, but it's a cold temperatures, and we want to keep that cold temperature outside. We want to keep the warm temperature inside. But anytime you have wall space, you're losing that heat to the outside. It just has its way of getting out. And I won't get into detail. We touched on that 2 weeks ago, and you can review those videos if you're interested. But option B on the top, it has more wall perimeter space. And so not only is it using more building supplies perhaps, but it also allows more heat transfer to occur because it has 1.25. It has more than a quarter more wall space for heat to be lost. So you typically want to stick with those more consolidated, compact designs. Same kind of bit of information shared on the bottom. A simple square studio apartment, about the same floor space as option B. That option B is just a much more convoluted design. And so from an energy standpoint, option A, that simpler design, has less wall space. You're going to lose less temperature, less heat through the walls of option A. Now, an architect might differ with me, but I would say just from an energy standpoint, option A would be better. Now, aesthetics come into play and other aspects there, but the simpler designs typically have better heat retention. Now, the orientation, I'll talk about this as well, how the house is situated. So if you're designing and building a new house, you might want to decide which way your front door is going to face. You might be restricted by the lot that you're working with, or even if you're going and purchasing or renting a new home, you might want to look at the way that the unit or the house is facing. And so I've given 2 options here, again, option A and option B. And so they're just rotated 90 degrees. And so they're the same house in this example. They're just rotated 90 degrees. But what you'll see on option A is that you have that morning 7 a.m. sunlight shining on the east side of the building, and then the sunlight shining. I think I have that reversed, don't I? I do have that reversed. The time is reversed there. It should read 7 a.m. from the right to 7 p.m. on the left, but you get the idea. You have early morning sunlight shining on the east side, and you have late afternoon sunlight shining on the west side of the house. So again, because you lose heat going through the wall, you typically want to have your smaller, shorter walls to the east and west, and you want those longer walls to be to the south or to the north, where you're not going to have that heating on the sides of the house. So that's another thing to keep in mind. Room layout also has an impact as well. And so when you're looking at a house, maybe to purchase or to rent, you want to pick one with a good room layout in terms of managing the heat. And so I'll give you a couple pointers here. The primary living areas like the family room and the living room should be towards the south of the house. And again, that gives you better management of the sunlight coming through the south. It gives you better management of the temperatures as well. And, you know, we'll look at ways that we can kind of balance the temperature and light. We do want light to come through our windows, but we don't always want the temperature to come through in the summertime, especially. You don't want that heating up your living room and family room areas. But we'll talk about ways to manage that. But typically those primary living areas, put them towards the south side of the building, which I call the front, but let's just call it, try to stick with that convention of the south side being those primary living areas. Heat generating areas like the kitchen. Kitchen has a stove in it, laundry room has a dryer. Those are generating heat. And so you typically want to have those on the south side of the building. And so as those machines are operating in the laundry and kitchen room, it's on the north side of the house. So you're not going to have that heat building up unevenly. Okay, you're going to have it on the north, and the north never gets any sunlight. So you're going to have a little bit of balance there. And then buffer zones on the east and west side. And so you'll have buffering on from bathrooms and closets and things like that, staircases or whatever it may be. And that'll help manage that afternoon temperature in the west and the morning temperature on the east side of the house. And now with windows, and windows is something we talked about a couple weeks back as well. We looked at energy efficient windows and easy retrofits to improve their energy efficiency. But you typically want to have those, most of those windows on the south side, again, to let the light come in the winter. You don't want to use too much artificial lighting. You want to use more natural lighting if possible. And to balance that with temperature control. So most of that's going to be on your south facing wall. You can have an overhang, an awning, window shades. That's what I mean by treatments. You can have window shades or curtains or blinds to help regulate temperature in the summer, but typically you want those windows toward the south and less on the other sides. And then we'll have a couple notes here just to share on thermal efficiency. So, you know, one thing you can do is, you know, simple in those cold areas, you can do simple insulation. And what I mean is not, you know, what we've talked about previously is wall insulation, attic insulation, but here insulation, I'm just referring to simple rugs that you lay on the floor and that'll keep your feet warm. Those kind of simple kind of measures that you can do. You can also do what's called a cool roof. And I don't think I shared any pictures of this, but cool roof is just using a highly reflective paint or surface up on your roof to reflect light. It does not have to be white. There are darker options. But what a cool roof does is it reflects most of the sunlight. And so that benefits you in the summertime, reflecting that light off the house. Thermal mass is something, I did share a picture of this. Thermal mass would be like a masonry material that you do on the floor and walls, and it absorbs the heat coming through that south side of your house or apartment. Okay, and so here's how that thermal mass looks. And so you have that winter sun coming through the south facing windows, and the thermal mass is a brick or stone or something like that, absorbs the heat, and then at nighttime it dissipates that heat. And so there are some benefits there. There's some limitations to it in terms of the cost and design associated with it. but I don't have time to get too much into detail on that, but that is an option. And then again, I think this illustration does a good, gives a good example of blocking the sunlight in the summer. So you have that roof overhang, or like I said, you could have an awning or some kind of shade system there. We'll talk about landscaping for additional shade as well, but that'll block some of that additional light in the summer, because you really only want that light to come through in the winter. And we'll spend a little bit more time talking about that. Now, let's shift gears and talk about some of the home energy ratings that, there's a lot of different rating systems out there. Many of those are based on the IECC, the International Energy Conservation Code, IECC. You've probably heard of some of these, the Energy Star. We've talked about that previously, about Energy Star ratings for electrical appliances and things like that. You may have heard of some of these others, the LEED, LEED for Homes program. We're not going to talk about each of these, but just to give you an idea of some of the ratings. Again, a lot of these are based on that IECC building code. I've included some resources here. So when the recording and when I post this presentation on our website, you can review some of these references as well if you want more information on those. But I believe Maryland's building code is still using 2018 IECC. The IECC did release a new building code this year. Maryland hasn't adopted it to my knowledge, but I'll talk about what goes into some of that. What I do want to share is just the basis on, as I'll discuss, a lot of these ratings is kind of relative to the HERS HERS index, and that's what we'll spend most of the time talking about, the home energy rating system. And this chart that I've shared now is kind of giving you a picture of where all these other benchmarks fit on that HERS index. And so it's a useful way to kind of compare all these different indexes. The one thing I'll point out is, the farther left you go on this diagram into that green region, that's your better energy performance. And so there at the HERS value of 0, that would be a zero energy home, meaning the home is producing as much energy as it's consuming. And so it balances out there. You can go farther to the left. You can actually produce more energy than you're using and have a negative value there on the index. But we'll kind of stop our discussion at the 0 energy home. It's kind of a goal to strive for. So, there's a lot of different standards. You'll see the Energy Star version 3 kind of fits in with the 2009 IECC, but that's been updated a number of times. But I think I have another graphic. This might be a little easier to follow. What I will say, just kind of point out, most of the older homes, like my home was built in, I think, 1984, 1985. It's a little bit older and it has a higher value. So this chart is flipped left and right from the previous one. But those older homes, the less efficient homes, are going to be upwards of 100 or more. Most conventional homes that are built to code are around 100. And then you have different ratings going towards 0. Now, again, most of these ratings, the home energy rating system is based on IECC as well as Energy Star and many others. And so they assess through simulation and energy auditing. They assess a lot of these performance factors. And we've talked about most of these in terms of insulation, water heating, and heating system efficiencies, thermostats, and other aspects of a home. It's just taking into account all of these and giving you a metric. In the case of the HERS, you're getting that HERS value. There's some resources there, but again, this is data that I've showed on this slide is for Climate Zone 4. If you're in Garrett County, you're in Climate Zone 5, and you can look up information on the resources I've shared here, either at Energy Star, or you could look at Maryland Energy Administration for more information on code requirements here in the state. I've shared this information from the EnergyStar.gov website. If you're interested in some more information on Energy Star ratings as well, there's about 4,000 homes in Maryland that have been Energy Star rated, and you can go into this EnergyStar.gov website and look up some information on those homes and some of the energy savings and greenhouse gas emission savings that have been achieved there. The other resource that I'll share is Net Zero. So there's a Tour of Zero website. It's energy.gov. And I've pulled out just some examples here, filtering for some houses in Maryland, those that have reached and achieved a home energy rating of 0. And so I've shared one listing here. So you'll see the HERS index is 0, meaning they're producing just as much energy as they're using, and some of the features that went into the design of that house and how that was achieved. And so you can look at that information, and as well as for any other state, but I've filtered some from Maryland here. So that, again, that's energy.gov.